Okay, so let's go ahead and start covering the camera tracker. The first thing that I have is we have the two plates that we're going to be working with. These two plates we showed you guys later, actually before, so that way you're already familiar with them, so there's nothing new. It's the same two plates that you guys are working for the challenge. So the first thing that we notice, of course, is the amount of noise. That's going to introduce some issues to the actual plate. So for that reason, we went ahead and we did a denoiser and stuff like that on the last class, and then we exported out the denoise elements for us to track. Now, in this case, I render out JPEGs. You should never use JPEGs for this part. If you're in production, it will be a little bit different for that. But we have less amount of noise, but also a lot of artifacts. So the problem of why we don't use JPEG necessarily for production when we are actually working inside of Nuke and stuff like that is the amount of artifacts that we will have in the plate that could actually introduce some issues. Now, we still are able to see the details, but there's a lot of blockiness. And at that point, I'm better off actually working with the original plate that was given to us, provided to us, okay? Now, if by some reason you need it to denoise, you already know the process, so I'm not going to recover that. I'm just going to go ahead and put a noise selector there, denoise it, and then I'm going to go ahead and freeze the analysis by locking it. That way it doesn't keep calculating every single time. So now that we have that, essentially we have a very nice clean plate. You're able to export it out. Usually at this stage you pre-comp it, and like we said, you export it out and so on and so forth. Okay, so what we're going to do with this. So the first thing that we're going to do is add a new camera tracker node into the stream, right? So I'm going to leave the noiser there so you guys see it and that way know. But as I'm tracking, probably I will go ahead and disable it for this if my computer is not fast enough. All right, so we went ahead and we denoised the plate, we imported the plate, we denoise it, and now we start the tracking process. So what we got to do before we track? Anybody remember what we did in Syntheyes? Before you track, you got to what? Yeah, but for this one, we're tracking straight in Nuke. We're not taking anything from Syntheyes in this case. This is the case that you go into the studio, and essentially you don't have Syntheyes in your machine. The only thing that you have is Nuke. What the heck do? You have the knowledge of tracking. You have never used the camera tracker before inside of Nuke. You have used Syntheyes. So how do we apply the knowledge over? What is the first thing you have to do? Huh? You started with the blips, but we did something before that. There was a rotor shape. So that means we analyzed the plate to see the motion, the type of motion we were going to be working with. I'm going to disable the denoise so it doesn't calculate per frame, so that way I'm able to play a little bit real time. So we analyzed the plate and we noticed that this guy actually wipes every single track that we have available to us. Nuke's tracker is pretty intelligent, but when this guy's static here, Nuke will know that that's a static object. So essentially we'll go ahead and say, oh, this is static. I'm going to track that area, static enough. So it's going to put trackers in there and it's going to make it a little bit harder for us. So as you see, we have two or more things actually going on. The door opens. So the thing that you think you could track, all of a sudden, boops, no more tracking on that one. And then the guy comes out and it wipes every possible feature that you got in that area. Now, when the door stops right there, because the door right there is still moving. So when the door stops, let me hit spacebar here. Okay. When the door stops right there, right? You see this moving, moving, moving. You can't track it. You can't track it. And then all of a sudden it's done. It stops right there. Now we can track it. Okay. Now the cool thing is when he opened the door, it gave us a lot of tracking features on the inside, right? That before we thought lost. But there is a problem right here. As the lights are coming in, remember that we need to have like a healthy amount of trackers everywhere in the scene. We have a change in variation on luminance. So that will throw off any tracker, but you will see how Nuke works on that, and you're gonna like it a lot. And also, it will try to track this pond right here, and that pond has a lot of reflection. So essentially, it changes the highlights. So it seems something that is good for us. We could track it because we could look at the beginning of that pond right there, and we could actually do a manual track, right? And kind of stabilize that, but then, whoops, it gets white. We don't see it anymore. So there's a lot of challenges with this shot. It's not easy, right? So let's see where Nuke actually shines here. So knowing that we have this element moving, we have lens flares moving that could get confused as tracking operations, let's see how the heck we actually do this. So the first thing that we need to do is, after analyzing the plate, like your colleague said, we're going to go ahead and introduce rotoshape, masking operations, to help the tracker figure out what the heck is happening here. So for this, sadly enough, you're going to go ahead and you're going to roto. Okay? Now, one of the things that you could do is that you could either do a quick manual roto or spend your time tracking that guy and try to roto that way, or do something that we call a planar tracker. That is another way of actually tracking a plate when something like this happens. Now, planar tracker will give us pretty shitty results with the guy, but at least it can give us something that we can use for the roto to follow. So let me show you very quick how you can use the planar tracker with this. And if it crashes, don't spend your time, don't waste it on it, okay? Just try it very quickly. If not, move on. So let's go ahead and do a quick rotoshape. So the first thing that we're going to do is we're going to go through and we're going to find an acceptable frame. Like right around here is probably where I want to start tracking this guy a little bit more. Like his head right there kind of holds pretty well. When it's coming up like that, it kind of rotates too much. So I'm going to start from right here, from the center. And I'm going to go ahead and create a quick ellipse like that around his head, nothing too fancy. And I'm going to use that first to track. I'm going to make it pretty small, pretty tiny, like that. So that will make it easier for us to track. And I'm around frame 95. So I'm going to right click on top of the actual roto. Whoops. Don't delete it. And I'm going to select planar track. It's going to change to a purple color, and now it's going to give you all these other options at the top. Now, when in CFM you covered this, it kind of show you a little bit of how the planar tracker worked, right? You guys remember? Maybe not. Okay, no worries. Let's move on. Let's say you just saw this.
I feel like you're about to manually do this.
Oh, it could be very possibly the result that we get. All right, so now that we got this, I'm going to make sure that I don't have like the range of motion that is on the sides too much. So I'm going to take this, right, and I'm going to start tracking forward. So these are your tracking tools. And on the top right there, there's a couple of tracking options. Now, these tracking options for translation, rotation, scale, shear, and perspective. Now, what this means is not the information that gets calculated, but how the tracker sees the object that you're trying to calculate, right? If the object is only translating, that means there's no rotation to the object, there's no perspective shift or anything like that. It's perfectly fine if you only have the T on. I can't click when it's like that. So you only have the T on because it's only transforming, it's only moving. But if the object like this one is changing its perspective, it's moving around, and it's changing its scale and size, then you have to tell the tracker, hey, you know what? The object that I'm trying to track has all these type of motions you need to track. Now, if you have the 4 of them on, it's the best result, but it also takes the most amount of time to calculate, okay? So let's go ahead and try it out very quick. If not, I will end up with manual labor that is a lot faster sometimes than trying to figure out the tracker. So let's go ahead and track that forward. Let's see how much it holds. And at any point, you can cancel it and readjust it. Because what we're doing is just getting data. It's just a planar tracker. What it's doing is looking at all that hair, and it's looking at every possible feature in the hair, and it's saying all these are trackers, and it's following that shape, and it's calculating it. So right now, the roto, where is that? If I slide the roto stuff, it's not changing the underlying information. It's only capturing more data, okay? So right now, we got a little bit of that in there. If I turn on this option right here, I can see exactly what got captured. You see? It captured a little bit of perspective. So I'm able to actually switch that perspective. What it's doing right now is capturing just corner pin data, you see? That's what is going to allow me to either stabilize this head, or it's going to allow me to go ahead and do any type of roto and attach it to this type of track to be able to follow it through, right? So what I'm going to do is I'm going to continue tracking that. And you guys are going to see what is happening with this thing as I track. You see that it changes a lot. Boom, boom, boom. It changes perspective. Depends on the camera move. And we lost it, right? So essentially, we lost it towards the end because we have the hand that kind of wipes everything like that. So what I'm going to do is I'm going to go back here before the actual hand crosses. I'm going to delete all the data. Let's see if we can get close. So this area right here for us is if by some reason I find an area of the track that is really bad and I need to fix that, I could go back before that happened and I could go ahead and remove forward or backward data. So from that track forward, remove all that, or from that track backwards. This is similar to Syntheyes, where we actually went ahead and kind of shut off the tracker to clean it up, and then we went ahead and retracked that area, either with another tracker and combine it, or with the same tracker. That's the same idea here. You could clear all the data, or you could clear back or forward from there. These guys right here is to adjust this little guy that jumps around, okay? And you will see how that is used in a second. All right. So essentially for this, if we're tracking the car, we could do the same thing for the car. We needed to do roto around the car, around the roof of the car. The light is pretty static there, so if I need to remove the light, I could track the light and then do a roto around it to kind of clear it up. So there's a lot of little options that you got here. So I'm going to go in when we start losing it, right about that area, clear forward tracks. And then what I'm going to do is I'm going to readjust. I'm going to turn this off so it doesn't become obstructive. I'm going to readjust this really quick, right there, to capture a little bit more data. I want to capture some of this facial hair there. And I'm going to track forward again. It's going to crash again as soon as the hand comes through. And then I'm going to grab just a little bit more information right around that area. And I'm going to go forward a couple of steps like that. And forward a couple of steps. Now, you see that we're losing a lot, right? So at this stage, if there's no way of actually working with that, you could actually create something that we call a subtractive roto shape. And what is a subtractive roto shape? In this case, what is making that bump, you see that bump right there that happens? What is making that bump or that jump in the actual track? If you notice, the shadow itself goes over the face of the character, right? And all of a sudden, that's when we actually lose the track. So what about if we actually clean up a little bit of that before we actually track? So let's go ahead and clean up forward. And what I'm going to do is I'm going to shut off this track for now. I'm not going to track it anymore. Okay. And I'm going to create a new roto shape. But this roto shape, what we're going to do is we're going to use it as a subtractive roto shape, not for the planar tracker. So what I'm going to do is I'm going to go ahead and create a new shape that covers the area of the shadow and maybe the hand, but in this case just the shadow for now. All right? And I'm going to hand animate it, right? Moving through very quick. All right. So now that you do that, essentially, you're able to remove that data. As long as the actual shape is on the top, this will become, like Syntheyes, a garbage. Okay? So anything that is above will subtract from anything that is below. So now what we could do is we could go back to our planar tracker, remove the data, the bad data that we have from that point where the actual jump happened. Okay? And let's go ahead and track forward from there. So I'm going to track one frame at a time. All right. And that's where the adjustment happened. And all right. So now let's see if we could actually adjust or add any other type of shape in here. Let's go, whoops, there's a jump right there on the roto. Let's take that. All right. And there's another one there. And there's another one there. Now, look at the amount of time that it takes just for the planar tracker to just do a roto later down the road. So this is where you analyze, okay, What is faster, doing the hand roto or doing the planar tracker? You see? So this is where you have to decide. As you go through this, right, is working. Now I could export a data out of this. I could go ahead and say, all right, I'm going to export a tracker out of this. Then I could go ahead and take a new roto. And I could set that tracker to a match move, for example. Okay. So now, if I do have that data now, I could go back here to where we started, like right there, right? We could go around, rotoscope the guy. So let's go boom, 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 and then around, okay? Set this to a mask very quick. Now, as we move, let's see if we got any type of data operation in here. Boom, boom, boom. Set this to match move and frame set to current frame. So essentially now what happens is that the data actually travels with the character, right? Now I'm going to take the parts that it crashes out and I'm going to finish the roto with that scenario. But you see, we're having a little bit of data. We're able to actually track and use that. Now you always have to gauge the time that it takes you to track in the 2D planar tracker versus the time that it will take you to do it manually. Okay, so right here I'm going to stop and I'm going to start doing a manual labor there. Boom, boom, boom. The guy goes in. We're going to keep the door in the mix. Boom, boom, boom. We're going to go down a little bit like that as the door closes. And we're good. And right there, we're going to take the rotor shape and out. So as we go in, boom, boom, boom. Right there, he stops. Okay. And now you do the micro adjustments for this part. And let's delete that. So what I'm looking for is his body, the majority of his body to actually be holding in that location. Okay. It's like, what the hell, man? You left me alone. And we're pretty good. 224, I think, is this shot. So we did a little bit of camera track, planar track, in order for us to be able to do a little bit of that roto. So now we have a quick roto to garbage mask everything out. Now, so that's one solution. This is the planar track solution. So essentially we went through and we did a planar track for the purpose of doing a roto. Okay? Now, this will be used later on in the actual match move. So we will show that. Now, the other option that you have is completely doing it by hand. And the last but not least is actually trying to pull a key. Now, when we do a keyer, remember that I don't want to track all these lights and stuff like that. And that's the other thing I have to roto the car. But with a keyer, right, we could go ahead and take a look at the luminance channel. And I could try to key out as much of those arms and anything that is a reflection as possible. Okay? So I'm going to try to do this. Anything that doesn't have any contrast, I'm going to go ahead and try to wipe it away. All right? So that will be one other option that you could actually do. And this one works with the shines. All those shines, right, that move. See the character, you see everything else that moves. All that is getting now also matched in the sense of the track. We could add a little bit of track cleanup in there if we needed to, but that's pretty much the majority of it. Now, in order to support the character, I already have this masking here. So what I'm going to do is I'm going to combine that mask. Let's duplicate this so it's two different methods. So I'm going to combine these two mats. I'm going to set this to a screen. actually a max. So it's maximum. And now we have the track where it needs to go. We have the hands and stuff, guarantee that the guy is not going to be covered or anything like that. And we have all the reflections kind of covered in that scenario. All right. So essentially that's kind of the idea behind this. It's actually to kind of give a little bit more help to the actual tracker in order to do its job. So let's do a quick roto here. Let's do one more. And what I want to do on this one is I want to keep, in this frame, I want to keep this bottom area so I could track it. So I'm going to mask it out from the original. I'm going to use a B-spline for this. All right. And I'm going to mask that out from here by doing a stencil. That is the opposite of masking, so it goes black like that. All right, so let's go ahead and track that very quick by hand. All right, making sure that it stays with it. And off a reflection in there. Got it. You got it pretty good. All right. And right there, we're gonna just clear it up. All right. So we got enough in there to actually do our job. So now we can move forward. Okay. So now that we have that, that's our masking operation. This is a little bit of aid with manual labor as well. So Shift B, this will be a key method with some manual work. So keying with manual. All right. So now that we have this, that's all the preparation that you have to do before you actually start a track. You do it in Syntheyes when you have complex shots. You also do it inside of Nuke when you have those similarity or similar shots as well. So this is using the planar tracker. This is using manual keying methods in order to be able to extract what you don't need from the plate in order to be able to do a proper track. So the next thing that we're going to do is we're going to go ahead now and connect that to the camera mask input. A lot of people, you will see that they connect it straight through. You could connect all that pipeline straight through by copying it through the source and then use the source alpha. It's the same thing. By having this mask on the side, you just isolated the area so that way it doesn't get confusing. If not, I will have to put all this right in between here, and I don't want to do that. So again, in YouTube, there's misconceptions there. A lot of people, oh, just put the rotor right in between here, and that's fine. Either way is fine. For the purpose of organization, keep it independent like that. It's an area, and it's easy to see what it is instead of trying to dig it around in here. So we're going to go now into the camera tracker. So the second part is now tracking. So we prepare the source, and now we're going to track the source. So with all that information, what do we have to do? First, I got to see what is going to get tracked. So for that, the camera tracker will have a couple of tabs that you're going to be looking at every single time. So we start with the camera tracker tab. This is the equivalent of when you open a footage, that pop-up window that tells you put this information here. That's the equivalent of that. So you will put all the information that you gathered right in that area. Okay. We're going to tell the type of camera motion. This is a jib move. So there's a free camera. Okay. We have lens distortion. If we don't know it, we want to calculate it. So you could turn that on. So we're going to turn that on. So as is camera tracking is also calculating the lens distortion. That's the equivalent of Syntheyes calculate lens distortion. Does that make sense? So we're trying to assimilate the two. Now, focal length, this is the same as Syntheyes in that area, right? The focal length, unknown vary means that it's zooming. That's a zoom lens. Unknown constant means that it's a prime, so it's not moving at all. It's not zooming at all. And then approximate constant and vary is that if you have a number that you think is the closest, because you were on the set and you thought, oh, I think we shot with a 50, then you could put an approximate vary or approximate constant. What it's going to do is going to help the tracker, and the tracker is going to say, well, you put a 50 there, but it's not quite a 50. It's about a 47, something like that. So the tracker will allow you to do that. If you put known, that is the other option that you have. Known means that you actually know 100% what is the actual tracker's, damn it, clicking. So if you put known, oh, that got recorded. If you put known, you know what the tracker is, okay? Or sorry, what the lens is. So if it's a 50, you know, oh, this is a 50. There's no way around that. Now, in our experience, every lens has a little variation. It will say 50, but it's actually a little bit less or a little bit more in the percentage. So usually we always, even if we know, we use approximate constant, stuff like that. This time we don't know. So that's the equivalent of Syntheyes setting that lens area on the solver panel, okay, to know or not known, or in the automatic set. Film back. That little pop-up window that asks you, what is the film back of this camera? You guys already know this one, right? So what is the film back for this camera? Anybody? It's a Sony, and we're using an EX1. So by default, Nuke gives you that. You see, Nuke has all the settings in there for a lot of the cameras. So all of a sudden, voila, our setting is there. So we use Nuke as a cheat for Syntheyes if we don't know a specific camera. Usually the film cameras will be here. And we will be able to find very quickly the stuff if we can't research or we don't have internet on our connection or anything like that. All right, so the EX1 right there, automatically, I remember is 6.97, so it's good. So we're good on that. Now, the next thing that we need to do is applying our mask, right? So in this dropdown, you have what you're trying to track. So in this case, we're tracking a sequence. And what is the mask input? Well, we want to use the mask alpha. Mask means the input that is called mask. That's what that is doing. It's taking the alpha of that input that you just connected called mask and is using that alpha. All right. Now, before we track, we need to check to make sure that that mask is getting applied correctly and it's not tracking the opposite element. So how we do this? If you go to the Settings tab, you will see something called Preview Features. So if you click on that, it's going to show you a quick, let me see if I can get it to click. No, I can't. It will show you a quick preview of what the tracker is going to be doing. And you see right now is inverted. It's actually tracking the inside of what I wrote out, not the outside. So what I need to do is go back to the camera tracker and my mask input, invert the mask. Okay? And let's see. Oh, duh. Let's put it on the alpha, make sure that we have that, and good. All right. There we go. Let's see. Let's find other frames. That means it doesn't have a lot. So it can't see almost anything on the shot, which is a problem. So this shot is very bad. If you notice, it doesn't see almost nothing in there. So I can select the character, right? And that's the other area, or I could just invert the alpha and try to select that. Wow, that's a lot of bad stuff. A lot of bad jujus in there. All right, so that is bad. So what we're going to do is we're going to try to shoot more points at it. So we're going to kind of lower the feature separation. Back into the Settings tab. I'm going to try to shoot a little bit more towards it. So I'm going to, the detection threshold, I'm going to tweak it if I could click on it. I'm going to change the detection threshold to be a little bit less, not be as strict with where it places the tracker. So I'm going to lower that a little bit so it doesn't have a high threshold. And I'm going to take the feature separation and I'm going to either lower it or increase it, depends on what you see on the screen. If you increase it, it will create like a grid pattern on it. It will spread the trackers apart from each other. It will try to force them to be more than this amount of pixels in the separation. If not, if you want them to clutter or cluster, then you can lower the feature separation and they will cluster together, you see? So I'm going to go up a little bit to kind of evenly spread the trackers, just a little bit, not a lot. So I'm trying to evenly spread the trackers to see if we could find anything. And those trackers don't last long. And you see one on the top is flickering like crazy, which tells me that we're going to have a lot of problems with this shot. Okay? So we're going to have to do some manual tracking on this one. All right. So now that we have that, I can even see still the hands of the guy in there. So I might do a little bit of preparation, more preparation here. So let's do a grade. And as I do that, let's take a look at the features. open it up like this. So it's going to be floating here in space while I do this. And then the other one's going to be here. By holding the command, you could float a window. That way it never closes. That way you could work in two that way instead of having one on top of the other here. You could put on 2 monitors. If you have 2 monitors, you can move the windows around. It's a little bit easier. All right, so what I'm going to do here is I'm going to change only the alpha. I'm going to start changing this value here to kind of cluster just a little bit more that area or that. So I'm pre-treating the alpha just a little bit more. Essentially, if you want to see what it's doing, just going in and changing just a little bit the information. Refresh, come on. I'm going to add a erode. Whoa. Kind of expand it just a little bit more around the edges. All right. All right. Now we're going to see what happens with the data when we actually have a roto, when we don't have a roto, see which one gives us the best. Remember, we're using Syntheyes procedure inside of Nuke to see what we get out of it. Now, so I'm going to go ahead and load the property panels, close this camera tracker up, double click on it to load it back in. So now that we have that, we have our mask input alpha, mask inverted alpha. So now that we have that, we tweak our settings. Let's add a little bit more. Let's shoot more points at it. So you could increase this feature amount by a lot, and then we could push them away from each other a little bit more, you know, just kind of cluster them around a little bit like that. All right. So it can't find anything on that area at all. So it's actually finding our rotos more than anything else. So let me go ahead and do a clamp on my roto. That means the roto might have negative values, so clamp. All right. And double click on this guy. There we go. So if a rotor shape has negative values, definitely we'll go ahead and do those type of operations. So now we can see a little bit more in this area. So you see by doing a clamp, look at the difference. That's before. That is still capturing our characters because we have negative values within the actual alpha. And then that's after when we clamp the alpha to make sure that it's 0 to 1. Every alpha should always be 0 to 1. Okay? In Syntheyes, you won't have that problem because Syntheyes, the alpha is internal. So automatically it does 0 to 1. It does its clamping and knows what to do. All right, so we got now the rotos are shown like that. We got an even separation of all the points. So now we're ready to track. So how the heck you do the track? So it's very easy. Everything that you need to do is right in front of you underneath the analysis. So you saw the steps. So we first started with the input, then set up all our camera data, and now we're going to go to the analysis. That in Syntheyes was from the left to the right. This one is top to bottom. Usually how we work in Nuke, right? Stackable mode. So in this case, I'm going to go ahead and take the analysis, and I'm going to turn on the track, right? And now we're going to let that roll. If you see I'm not looking at the video, you should. I'm looking mostly at the alpha. I don't care too much about the video right now because it's doing its thing. I can't control it. So no matter what I do, I can't control this. It will keep going, right? So that means looking at the video won't make any major difference than not looking at it.
This is complicated.
No, this is actually easier. Well, it seems complicated now, but you'll see. Because in this one, we have to do more work with the roto. In Syntheyes, you still haven't done complex roto. When you start working in Syntheyes, you're going to realize Nuke is far superior in roto than Syntheyes is. So it will be a lot faster. Yeah. Because Syntheyes is superior in the sense it's a software just for tracking. So essentially, you don't only do tracking, you could do planar tracking like Nuke does, but Syntheyes is better. In that scenario, you could do texture extraction. You could do stabilization, 360-degree stabilization and tracking. You could do object tracking with geo tracking combined. You could do object and scene tracking combined. You could do mesh deformation combined with object and scene. You could do dust only independent, one or the other. You can't do that in Nuke. You see? And the amount of softwares that you can export it to is almost every package in the industry. Nuke, you can't do that. You have to export it first. You have to do a lot of little things to do it. Nuke, you have to export the FBX. If it's going to go to Maya, you have to do it one way. If it's going to go to Blender, another. If it's going to go to another. So you have to do a lot more work. This is kind of, I use it a lot because it's one solution. I click go. Sometimes I don't even do masks. I will show you when that works and when it doesn't. All right, so it's done. The next thing that we have to do, like you did in Syntheyes, is solve, right? After you track and you did all your stuff, you solve. So you click on that solve mode, and it's going to go ahead through the solver, and it's going to give us an error. Usually in this scene, it's pretty high. So now is when we have to deal with this problem. So Nuke is a lot easier in a lot of sense, but it requires a little bit more massaging of the footage. That's why we denoise before and stuff like that. This one I left it without denoising. So you see all that jitter that happens on the trackers? I put the denoiser there, but I disabled it. So you can see what happens if you don't denoise your plate. Every night shot is always a nightmare. Now, when it takes a little bit too long like that, you know there's problems. All right, the same with Syntheyes. If Syntheyes takes too long to solve, you know there's problems. Okay? So, it gave us an error of 1.17. Unbelievable. That's crazy. Usually when I did this one, it takes like 5 from the beginning. But I don't do the rotos. So the first time, yeah, it's always like that. Wow, that's great. 1.17. But it sucks because this is a 1280 by 720 plate. So we need to be below that 0.7. So that means we're doubling the error amount. So let's go ahead and see how it did. So in this case, we have a couple of things, right? We have the plate, but we have red trackers, we have yellow trackers, we have green trackers. And in the areas that we didn't want to track, pretty much by doing the cleanup work, it already did a lot for us. It actually went ahead and cleaned up all this garbage of the guy moving through. And then the car moving through, and then the highlights moving through. Now, the green ones means they're okay. Now, these are the reprojection errors. This is the equivalent of Syntheyes. Remember, Syntheyes has two type of markers. The green one, right? That is the one that you track. If it's a diamond, it's automatic. And if it's a cross, it's yours. It's a supervised. And then it has the X, the yellow X that shows you where the 3D track is. Nuke is no different. In this case, the black one is your 2D track. And how far that is from, you're going to see a little line in between the two. And this is your 3D scenario. This is where it actually is, vice versa. Or the opposite, or either way. I can't remember anymore today. Now, right there it gives you all the information about your image. So essentially, it's telling you the track, what is the error on that track, how high it is. So this one is it's a little bit higher sometimes on the max error. Max error is when it peaks. Every tracker has its value, and then all of a sudden, in 1 or 2 frames, it might peak very quickly and jump back down. So the max error for this specific tracker is 1.4. That means at one point in its life, it peaks to 1.4 and then comes back down. The average error, the reprojection error between the 3D and the 2D is actually 0.832. So that means that's how close the 3D and the 2D are from each other. Now, it's different than the error that is the max error. Does that make sense? Because the error max just tells you this tracker at some point it goes all the way to 1.4. And now the RMS is telling you from the 3D track, from the 2D track, your 3D tracker is this amount off. Does that make sense? So it's a little bit different, the data. People tend to confuse the two. All right? And the overall error for the tracker, the combination of everything, is 0.412. And it tracks for 19 frames, which is not that bad. If you see one that tracks for 1 frame, that's a problem. But you can see how this tracker just jitters like crazy. All right. So now that we have that, the green ones means they got solved. They're good. The red ones, they suck. No way, Jose. You're not going to get those to lock. And the yellow ones, they didn't even bother. It was so bad that Nuke didn't even bother solving it. The algorithm says, yeah, forget about those. I'm not going to even try. All right? So now we're going to do the cleanup. So now we're going to go into solver refinements, right? That is what you guys do in Syntheyes. So in Syntheyes, after you do it, you don't want to retrack anymore. You want to do a refinement operation. So what you go is, you go to the auto track section, okay? And in the auto track section, you got your traditional solver refinements. In this case, they're similar to Nuke, similar to Syntheyes, the same way. The only thing is, this is your graph editor in Syntheyes. Does that make sense? That's the graph editor right there. The only problem is it doesn't show you every tracker in its entirety. So what we need to do, our goal is to lower the error, but still keep healthy amount of trackers on the scene to be able to solve it and move the camera around. Two things need to happen. At the bottom, you notice that I have a blue line that covers my whole sequence. If I go too low or I clean up too much, the same that happens with Syntheyes, I will start getting gaps on that blue line, and you will notice it. All right? So let's go ahead and see how do we clean this guy up. I can't zoom in. All right. So the first thing I want to do is delete unsolve. All the bad ones, you click once, yes, it's going to get rid of everything that is the orange-yellow color. Okay? Now, delete rejected is all those red ones. I'm going to say yes. There's no need for me to keep them. Okay? Now, as we go through, we see how much it tracked perfectly. The car, when it was static, it tracked a lot. So that's what is going to save us. That car, after the door opens, that's what is going to save the whole track. All right? So now notice over here at the top, the per frame error. So let's see if I can move this slider. I'm going to hit play very quick, leave it playing, and then I'm going to zoom in and see. No, it won't allow me to do that. Oh, yeah, it will for this one. Come on, you could do it. So a per frame tells me how high the error is in a specific frame. So remember in Syntheyes, you saw it by the camera jumping. Here we don't see the camera jump, right? Because we still haven't had a camera export. So essentially in here, unlike Syntheyes, in Syntheyes you already have a camera export and you could see the camera working. Inside of here, you have to explore the camera if you want to do that. It's a little bit different. You could do the same process, but let me show you without the camera first, how we actually analyze it, and then I'm going to show you the trick similar to Syntheyes with the camera in there. All right? So in this case, now that we have this, over the top, you could see the actual per frame error sliding. So there's a little number. Don't worry. I'm not going to say trust me, because if somebody says trust me, you don't. So essentially, if I can't move this guy. All right, this per frame right here, you're going to see it moving, okay? Struggling with this thing not to be able to click on it. Now, this is the solver error. Our goal is to take this guy down, and we got to find the highest frame right here that has the highest error and remove it as we can. Now, this is like Syntheyes. Automatic is better, right? So let's go ahead and select. First, let's start with our max error. At the bottom is the sliders that you could actually tweak for getting rid of the error. Right now, the max error in the overall scene, that means there's a track right in here that the highest value that pushes the whole scene is to 591. So this on the left right here will show you the highest value. This on the bottom will show you in the frame that highest value is located. So let's see. If we're going to clean up max error, we click on max error here, and we're going to see a thin line at the top. That's our threshold, our slicer. It's like a knife. Okay? Now we hold down the command key, and what do we want to see? Oh, we want to see the error max. Okay, let me zoom out. Click, and now we don't even have to look at this. Now we got this guy. So what we're going to do is, if you notice, when I take the max error lower, you see how it's slicing all that data? So you can see right here is where our tracker is jumping the most. So what I'm going to do is I'm going to try to move it down here, and let's focus it here as well and see how many trackers get removed. If I go lower like that, you see all those red trackers? It's similar to the auto cleanup tab that we did in Syntheyes. Shift C, and then we click on show, and as we were moving those sliders to see the error, this is the same thing here. So again, if you know one software, you can apply it to the other. Okay? So as you look at this, if you go too low, you remove too much. But you have to be very aware. On the first couple of frames, I got to see how many trackers I have to make sure that if I'm going to slice it right there, I don't lose all the trackers in any of the frames. So right here we have very limited amount of trackers, actually no trackers on the left side, so we might have to do supervised track there. All right, so right here we might have to go just a little bit lower to kind of remove some more in there, and let's see, make sure that in no frames I lose all my trackers. Right there is kind of iffy, but now that we have that, let's go ahead and delete rejected. Those are all those red trackers that are above that threshold that I just set. Now my new threshold is below a 3, so I'm saying everything above a 3.2, remove that. So any error above that, you're gone on the max error. Remember the max error is every tracker has a max error. So that spike that is on every tracker is going to only disable that data that is bad. The same that you did in Syntheyes when we did the same similar scenario with the Shift C. Another word for this is the equivalent of going per tracker, unlocking the tracker, finding the highest peak, disabling that, and relocking the tracker. But instead of doing it one at a time, Nuke doesn't give you that list, you do it all at once. So it's mostly like Shift C in Syntheyes, that you can do all of it at once, okay? So let's go ahead and delete rejected and hit yes. And now you notice that I don't have any more spikes above that value. And my error got reduced to 0.96. Now, we still haven't refined. As soon as we refine, this error should go lower. And you should see new spikes pop up, okay, above that threshold. All right, so let's go ahead and select what do we want to refine. We want to refine a couple things. Remember that we're calculating lens distortion like Syntheyes, right? So we have to tell it to refine the focal length because lens distortion, focal length, they go together. We also need to refine the position of the camera so it auto-calculates the new path. Damn it. Sorry, that got recorded again. You're gonna have such a good laugh with this recording. So the rotation, same idea. We need to calculate the new rotation of the camera to make sure that it looks correct. Now that we have that, we're gonna go ahead and refine our solve. So when we do that, it's gonna take a little bit, boom, and it's done. So you see there's one tracker right there that is just spiking, no matter what we do. So as soon as that tracker spikes, or any new tracker spikes, it always will spike, even if you keep deleting stuff. But that tracker right there will be really bad. So as soon as it spikes, you notice that it automatically gave me new reds in there. So any tracker that was bad, let's go ahead and delete rejected again, hit yes. You see, it automatically auto-detected those trackers. Let's go ahead and refine again. You will see new spikes again. Okay, give it a second, it's doing it, and boom. You see that tracker still bad. Those are the ones on the background there. So you could keep doing that if you want that threshold, but that tells me that I could go even lower to remove those bad trackers that are there. So I'm gonna go just a little bit lower, and this point, it goes a little bit quicker when you do it on your own, of course. Right now you're learning it, so delete rejected again, hit yes, make sure that I don't lose all my trackers on the process. And if you notice, it's calculating the lens flare as well. That's why lens flares are bad for you for tracking. So you could actually select them and hit delete on your keyboard to remove. Even though if it thinks is good, you could actually remove them by hand. There's one tracker there that is committing like suicide right there. Hit delete. It's going in a different path. So you could also go in and manually remove bad trackers. So every tracker is going down, but these guys are going up. That tells you something bad about them right there. So let's go back in. There's a light stand right there. Remember that. There's actually a sandbag right there. Nuke was intelligent enough to be able to detect that through all that noise. Right? So that's pretty good. Okay, cool. So now we don't have any new spikes in there. So let's go ahead, and our error is 0.7. We're getting pretty low, so that's good. All right, so I'm going to go a little bit quicker now. So max track error was the actual error that every tracker will hit at some point. The max track error is actually the overall error of the track, the reprojection error, the RMS that you guys know in Syntheyes. So that deals even more with that scenario. So let's go command, and I'm going to select error track. So again, this is a slicer. These are the curves. Okay? Always remember that. These are the slicers that are for these guys. These are the curves. The ones that say error, 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 those are just the curves that show the error level. These guys over here, that track length, the max and the max track error, those are the slicers that you have at the bottom. So anytime that you want to tweak one specific area, you look at the name, minimum length, max track, and max error, and you find the two elements that correspond to what you want to clean, and you click on them. Does that make sense? It's a lot of data. I know. That's what advanced is all about. All right, cool. So now that we have that, I'm going to select those two, and I'm going to go now to my second slider, the max track error. And let's go down. And this one is taking the overall scene error. You see it's very nice and steady, and all of a sudden, book, starts crimping up. So it detects like a tire in there. Let's go back, make sure that I don't lose all of them in a specific frame. Right there is one I'm worried about. That one right there. All right, delete rejected. Yes, we're good. So now we cleaned up all that. We have a nice straight line. Let's refine the solve very quick. And now our max track error is below 1.2. So we have 0.7 on the scene, which is pretty good. Some frames are 0.6 and below that. So let's take it down just a little bit more. Delete rejected and hit yes. And that put it way below. So 0.6, which is pretty good. We can still take it further. Now, minimum length. In this case, the same idea. Error min and minimum length. In this case, everything is pretty good. They last pretty low on that scenario, so we don't have to tweak that one. So we can leave it at 3 to 12, and we should be okay. All right. So we should be, this one works the opposite. You want to increase the value, not decrease it. So you say anything lasting more like that, or anything lasting less. So I want anything lasting less than 3, so everything lasts more than 3, so we're good. Now, the higher we go, the more we're introducing into the clear up. So let's go 3 right there, delete rejected, the default, and we're good. All right, so we're 0.67 from 1.17 is when we started. So we're pretty good for this one. We're below the 720 mark, which is not bad. It's not perfect, but it's not bad. We should be half of its actual plate size. But now that we got that, we have our solve, we got our refinements, we did everything that we needed. Now it's time to export out the camera data. So how we use that? So the last thing is your exports, right? In Syntheyes, it's automatic. In here, it's at the bottom here. So the steps are from the top to the bottom. If you follow them, that's essentially how Nuke is set up, top to bottom. So in here, we have the camera. So what we're gonna do is export the whole setup, the camera, the scene, the lens distortion, all of it in one shot. So we're gonna go ahead and go scene plus is the option that you wanna pick for that, and hit create. So when we do that, now we have all this. There's our lens distortion calculation right here. There's our camera that we just calculated there. There's our point cloud data, so we know where things are at in 3D space. And this is the scene, the equivalent of the 3D scene inside of Syntheyes or Maya. That perspective view that you guys have, that's this. The camera with the scene, that's the perspective view that you will get in Syntheyes. And then this is the image plane. This background right here is the equivalent of the image plane in Syntheyes or the image planes in Maya. Same idea. So if you look at Maya Hypergraph, you will see this internally inside of Maya. Maya is a node-based system as well. The thing is you see the UI differently, but internally is all node-based. So let's go ahead and hit 1 in here. And let's hit spacebar, and there we go. So now we're able to judge this guy a little bit better. Now, there's the lens distortion calculated. I don't think that's correct. For me, I don't think it's correct. I could see the bowing on the car and stuff like that. So we probably are better off without the lens distortion in this case. But let's go ahead and take a look very quick at this. So now we could see our track, we could see the point cloud data, and we need to see if there's any bumps or jumps in that data, okay? So remember, the idea is to try to get as clean of the camera as possible, similar to what you did in Syntheyes. So the problem here is because there's a lot of automation, the amount of control that you have is a little bit more limited. But the possibilities of getting a shot done quicker, they're kind of higher. You get used to that auto setup, and you always expect the tool to do better and the algorithms to be better every new version. That kind of gives you an idea. So the roto that we did, even though it took time, it paid off. So we could see that none of the hand is being calculated. We have an actual parallax happening now. The car is pretty static, but we will see that as soon as the camera moves. Remember that the solver error is not essentially the camera path. We still might have some jumps in the camera path, so that means there might be a tracker around that we still need to remove in order to get a good camera path. One tracker could throw everything off. All right, so it's pretty good. Our payoff right there of kind of isolating the car area to make sure that we could track that area worked. All right. There's some trackers that we still could remove on space that they're not needed. Now, and you have to wait for this part to make sure that it actually renders and you could actually see it in real time to see if there's any type of jumps. If you see it like this, step by step, it never shows you any of the jumps. So you have to actually wait and check it out in the real time scenario. All right, so now when it plays back, let's wait for a second, and there we go. So there is a slight shift. We need to go ahead and clean up some more, but it's holding pretty well. So at the beginning of it, as the car is coming in, I could see a shift. We have to see if the camera is there. Seems like the door is bringing some of that shift in at the beginning when it opens. Yep. And then the car when it's coming in. So those background trackers are kind of bringing some issues in there. Do you guys see what I'm talking about? That little shift? So that means if you auto track it in Syntheyes, try it out. First, always try auto track and see what you get. And then go back and then do some manual labor to help the auto tracker and so on and so forth, and vice versa. But I can see a shift at the beginning, so I know that the camera is kind of off at the beginning. Then towards the end, it holds pretty well. And then we have trackers on the air. So those are the ones that kind of are deceiving for you guys. They are either above the ground, way close to the camera, or below, and those will be very deceiving. So that means there's more trackers that we could clean up, and that is a good idea, is a good result. So now the equivalent of Syntheyes, seeing the actual camera track and seeing your perspective and stuff like that. Now that we have this camera connected, the camera is automatically linked to the tracker. So any new change that we're making will actually be reflected on the camera. So now we have the setup the same way as Syntheyes, where we could actually see what we're doing and we can actually do that. I will do one more thing, and that is to create a card on the ground. So what I'm going to do is I'm going to click on some of these tracker points. I'm going to find a frame where I could actually see elements that should be on the ground, like these. I'm going to hit tab on my keyboard. I'm going to select them first, hit tab, and now I could see where the trackers are and see if we're lining up the ground or not. You see that they're all over the place, right? So I need to find about 2 to be able to give me what I need. So let's take a look through. There it is, the camera. All right, let's take a look through that camera. Camera starts low and then goes up and pulls back, and that's exactly what the shot does, but there's that jump that I don't like. All right, so we need to find points on the ground to kind of do a little bit of a card in there so we can find what we need to do. So I'm going to find points here on the back. I'm going to try to find points on the center here. I need at least 3 points to kind of get me a good plane. I'm going to hit tab and see if those 3 points will live within the same world space. And they not, right? If we look at those, that would be like horrible if I put them there. All right. All right, select these 2 and these 2 right there. So it seems like if I select those right there, that will give me a good solid ground. So let's go ahead and do that. So what I'm going to do is I'm going to select those 3. Yep, close enough. That one, and that one. Nope, that will be too far off. Too far off. All right, so those 3. So what I'm going to do for now is I'm going to select those three. I'm going to right click, create, and I'm going to say card. So when you do that, automatically a card gets generated for you, a 3D card. Okay? And that 3D card, I'm going to hit Option E so you can see it. That 3D card, I'm going to go ahead and create a checkboard pattern to kind of help me see a little bit more of what I need. So I'm going to hit Tab right here, hit F, and then select the scene and hit 1. So now what I'm going to do is I'm going to line up that with the ground, and we're going to be able to tell if something is off, way off or not. So I'm going to take the card right here, and now I can see the card that is rendered. So if I hit Tab here, we will see that card right there all slanted and so on and so forth. So essentially it's just a card with a texture. So what we could do now is we could go ahead and line it up with the world. So if I go ahead and say, all right, rotation, let's put this at 0. Whoops, 90 on this one. Z, 0. All right. And Y, let's do 0 to line it up with Z. All right. So you notice that I have that card in there. I'm like, whoa, okay, that's not lining up whatsoever. So what I could do, all right, so I know that's the place that I want to line it up. The problem is I don't know if that's going to work for me. So I'm going to make it semi-transparent. Let's go ahead and do RGBA, and let's take this, just make it like that, just a little bit. So we could see it semi-transparent. So I want this to move that way. So how we move the world, how you guys move the world inside of Nuke? Anybody? How you did in Syntheyes? What panel you went through? 3D menu, the lock button, move the world. Actually, click on the world and it will lock it automatically, or hole, right? To lock it automatically. The equivalent of that in Nuke is this. Because the Syntheyes software is this right here, that's Syntheyes right there. That's it. That's what it represents to us in a compositing package. It's just one node, one step of the whole thing. Because we're doing that, we select the camera tracker, and in this case, we have something called scenes, right? Scene is the equivalent to that 3D world or that 3D setting or section on your coordinate section, whatever. So scene is what we're going to click on, not output, scene. Zoom out. In order to be able to go in and set up what we need. Distance constraint, all of it. But at the bottom right here, there's the world. So here we could actually angle everything so the world will angle towards what we need. Does that make sense? So it's the same idea that you guys did before. But look what happens when I start rotating and stuff like that. So I'm going to say, okay, the camera needs to be lined up. So the first thing is how high the camera needs to be. Well, this camera is pretty high. If that guy is, let's go to the, I'm going to disable the markers very quick. The markers are given to you by these camera tracker points, equivalent to the Syntheyes when you export the trackers out. So let's go to the first frame, and as we move forward, you know the car. The car is going to give you the best lineup possible. You see that the car is on the ground? So what we're going to do is we're going to start angling this. So the first thing that we need to angle is the x-axis, and the x-axis will move it this way. It's the tilt, right? But it's going to move it from the center of the world, all right? So I'm going to put this guy right here where I thought, right? So I put it close to the car where I could know I could line it up and stuff like that. So let's go ahead and take the rotate, and let's rotate it out just a little bit. And you're going to notice something very quickly is that we are on the ground. But if I hit tab here and I go to my 3D view, you see that card is below the ground, right? So that means the camera right now, I'm basing it off the camera, not off the world. So if I wanted that to be high enough, I will need to place this camera on the 0, 0, 0 position. So that means taking all these values and zero them out instead of using the trackers that I set up. But that means they won't cross anymore. The center of that won't cross anymore through that tracker. So the possibilities of sliding, because now I'm guessing where it's located, the possibilities of slidings are greater. Okay? So if you know the height of the camera, you place it now. If you don't know the height of the camera, then you do it later. So I'm going to hit undo here, and I'm going to keep it where I placed my original trackers, where the trackers that I selected were, and that way it's easy to line up that way, and then we can move the whole world upwards or downwards if we needed to. At the end of the day, the grid is relative at that point for us because we're not even using it. So we're going to hit tab again, and we're going to start angling that guy just a little bit more. Now I got that. The next thing is I want to line it up with that car, so let's go back into the camera tracker's world. I'm going to have to move stuff in the y-axis. It's moving from the center wherever I set it up. All right. And then let's go ahead and hit play. And if it doesn't stay with a car, we know we still have some sliding. So if it doesn't stay with a car, we need to find the tracker on the car and then use that, or put a new track or a supervised track underneath the car. Let me go ahead and unlock that very quick. And I can see if it's sliding or not. Right now I can see the slide. There's a little bit of shift. And that's the keyframes that we still need to clean up. All right. So far it looks pretty good. And it's too high. Right away we can notice. And you notice how the center is shifting. Okay. And that's a great example on knowing that. We're above the character at this moment. So if you notice, very quickly, let's see if you guys could tell why it's too high, right? If you notice, it feels like it's too high, right? Why? Because it's moving faster. If it was moving slower, that means it's too low. Okay? But you see how it slides over that line? That tells you super high. So it seems like it is actually towards the roof of the car. In that sense, that area stays the more static. Look at it. So that means how high is that car? About pretty high. Maybe 5 feet. So yeah, so that means we need to lower it down 5 units, about 5 units, to kind of get it right locked into the ground or close to it. All right. So that means we need to move the camera up 5 units in order to lock it down. So it needs to go down 5 units, but the camera is the one that needs to go up because it's on a jib, right? So that's how you realize, oh, it's off, right? You could see it. You could see it and you can start judging if it's moving too fast or too slow. That tells you if it's on the top. If it moves the other way, it's under. If it moves this way, it's over. Depends on, you could see it. All right, so now that you have that, let's go ahead and say, it needs to go down 5 units, so that means I need to go up 5. That means there's a lot, so I'm going to have to do it based on centimeters there. Whoops. Right there. And I'm going to go first frame, last frame, and see if it holds pretty well. First frame. I'm looking for this amount, so you see where that tire is. You see that yellow? You could slide it front and back to kind of get it. So what I'm going to do is take this yellow line right here and move it, slide it over to this to kind of get where I need that card to be. So let's take translate and let's move it on X. All right. And let's go back to the tracker. And let's see. Last frame. It's about there. It's about on the tire. All right, let's see. Let's hit play. So in the world still need some work, but in the world of where I'm scale right now, it's not real world scale. So essentially I'm working in between. So 5 units will become about 0.2 in this case. Still need some work. Get it to lock down. I can still see some sliding, so it's still a little bit higher. That's pretty good. See, good. I'm looking at the left side. That's where the camera slides, and then the camera holds. We still have some sliding, a lot, actually. And that requires more cleanup, and it could be the lens distortion that we're drowning out. All right, but essentially that's how we start going about it. We need more cleanup of the trackers, okay? And the process takes longer because it's automated, right? You have to do a lot of manual cleanup work on the automation process. But essentially that's how we start lining up the whole setup. Then we will do models and stuff like that. Now, there's another way of doing it using the model builder. I showed you that a little bit already, to kind of figure out where things are at. a little bit easier. Instead of me trying to figure out the plane, I could actually go with the model builder, build something, and try to gauge it where it's going to be. So, everybody good so far? Okay. So now, so Syntheyes, in Nuke, that's the same process that we did in Syntheyes, but in Nuke. Building the geo, we did that, selected a scenario, same idea. We created the geo out of a selection of a point. So essentially, we always go back to this camera tracker, right, when we want to see the points that we're kind of dealing with. Now, so how do I create zero-weighted trackers in here? How do I create a little bit more of using the camera data? How do I use that camera data to create zero-weighted trackers? So the way to do that is actually using the model builder to create zero-weighted trackers. Now, we're not tracking, we're double tracking actually, but we're not really tracking. It's using the camera data, the tracker data is already there, and we're placing points to kind of calculate where things are at, which will make it easier for us to build. The point cloud is not very useful in this shot. So how do you work with the model builder? So in this case, I'm going to create zero-weighted points. So I'm going to take a source. Source will be the actual image. We will take it from the lens distortion. And then the camera will be the actual camera that we are using for the track. So let's go ahead and move this downwards like this. And then I'm going to be using that camera. Or you could Option K it, move it to the side, and it's a lot cleaner that way. All right. So what I'm going to do is I'm going to use the model builder to create some zero-weighted trackers in here. All right. So I'm going to hit 1 because I don't have something to actually gauge in the sense of modeling, right? Like I don't see a perfect edge. Everything is rounded. And if you look at back there, we will never get this to not slide because actually that's like a little hill, and then it kind of curves like that. So you actually have to model it that way, right? The road, if you go back there, the road is not straight, it's slanted for the water to go sideways and then out into the back area. So you're going to notice that you will try to line this up as much as you can, and you won't get it perfect. And it will always slide down here. It will start sliding more and more and more as you get back. So you have to model it somehow. So what we need to get down is where the car is going to be, right? That area needs to be locked. But, so how do we create a zero-weighted tracker? So the first thing is those two. After you have a camera, just connect the footage and the camera to the model builder. All right? Now the model builder, what we could do is at the top here, we could select the different type of shapes that we could do. So it's the same as the 3D build that you guys use in Syntheyes to kind of create the little objects. In this case, we have something called point. The model builder would turn orange, and that means it's active now to do its job. So what I'm going to do is I'm going to go in like this, and I'm going to find something to hold on to. So let's say I want to find something that I could track over and over and over again. So let's say, let's do the front of that rim, right there. I want to know where that top area is. All right. Actually, let's move it down right there to the bottom of that guy. So I know from there to the bottom might be a little bit yay high. So if I need to build a car, I could do that. So I'm going to go back, and you're going to see that the point moves and it doesn't follow. So you need at least 3 keyframes to get this guy locked down. 2 to 3 keyframes. So I'm going to move it right there. That's where his think is going. That's pretty good. Let's go forward. We get blocked, so we can't see that anymore. So I'm going to go to a last frame over there and see if it sticks close to that area. It's sticking close to that area, so that's pretty good. So let's put one more keyframe to kind of lock it down, make sure that is accurate as possible. Right about there. Okay, good, good, good. All right, so if I hit tab, and I'm on the 3D view, there's my first point where the vehicle is. See it right there? I don't see that garbage of point cloud data. I'm only using a camera and analyzing where that's where that vehicle is. Does that make sense? All right, let's put one on the back, on the part that is slanted going down, and see how we find that area. So I'm going to go back to the model builder, lock the camera again, and I'm going to try to find one back here that I'm able to judge. So I'm going to wait until the light is in on top of it, so it's easy to follow. All right. So again, activate, click on it. I'm clicking on the highlight, but I know already it's a corner there. So I'm going to visually follow it. You see how it moved? Let's go ahead and Put it back in there. Visually follow it. See when everything craps out. Go back a little bit. It's pretty good right there. And because the camera is sliding, you can never get it 100% perfect. You can get it pretty close, but never 100%. Alright, so let's see if it holds for that amount of time. So I'm going to go in, boom, that's pretty good. It's holding, holding, holding. Slides a little bit, that's where the camera slides, so it's natural. And then we move up. Alright, let's put some couple more keyframes. Alright. So let's go ahead and unlock the camera. There's the other point back there. Okay, so there's one there, there's one there. Okay? So now we could see how the whole orientation is. Alright, for the camera. We can see we're going up, we're going down. So essentially that's the whole process of the model builder to put like zero weighted trackers on the shot and stuff like that. So let's put one on the door, something here that we could kind of follow. See where the dashboard is. Let's see. All right, I want to find that part right there. So with the zero weighted trackers, again, with these point, I'm going to go ahead and click right there on the dead center of the car. Move the tracker right into position again. Move the tracker right into position again. And again, if the camera's sliding, there's nothing we could do too much about that. You just have to clean it up. All right, so now we can see it even through the windshield. So if we needed to clean up something on that driver's seat, we will be able to do so. And that's how you know if the tracker is actually, the camera sliding. You can see the tracker slides, and that's because of the camera, right? That means we need a little bit more cleanup on that camera. But there you go. So essentially you could build it like that over and over and over again until you get a point cloud that you actually could build upon, right? So that's essentially how the zero weighted trackers are or work. There's where the vehicle is, that's where that gutter area on the back is, and stuff like that. So that kind of gives you a little bit more detail or where the things are at in the scene. Okay, so that's how you can create different type of trackers for your stuff. The same, you could create geo for it as well. So if I need to create a geo for this car right here to make it a lot easier on us, let's create a panel of it. So I'm going to go ahead and create a card very quickly. Let's click and drag right there. All right, and I'm going to go ahead and see if there's any frame before that. And I'm going to try to isolate it to the door. So let's take to that highlight right there. We're not tracking at this stage. The track is already done. So what I'm doing is just following what is on the shot. So I'm going to try to follow one point straight up and down from that highlight right there, and then one point straight up and down right about there. All right, so now that we have that, we're going to check. The door opens. We don't care about that. What we need to do is I'm going to need to find exactly the same location on a specific point right here. Boom, right there. So if I go back, actually it was at the bottom. So it's holding a little bit better. We have the camera sliding, but other than that, we're pretty good. So you need at least a minimum of 3 keyframes to do the job. Oh, I put 2 next to each other. Damn it. All right, so moving on for that, if I hit tab, go back to my 3D scene, there it is. There's the door panel from that car. So if I need to clean up that panel, that's how we will do it. All right. So essentially we need to bang up this guy. Let's say he actually was in a crash. We could build the vehicle, or we have a model of this vehicle. We could line it up that way by bringing in the model. And then we will be able to do our, let's say it needs to be like a collision and then the bumper is on the ground and stuff like that. You could do a map painting to simulate that stuff and make the bumper look like it's screwed up or something like that. If it needs to be a flat tire or something like that, you could paint the tire, make it look horrible, and then do the rotos for everything else. So essentially, that's pretty much how the model builder could assist you on the process of creating the setup for your scene, like a modeling of the scene. This one is a little bit, I love it more than the one in Syntheyes because of the simple reason that we could extrude. So if I'm locked to this, I could actually now go in and change my mode to edit. That is the second one down here. I could right click, select the edges, for example. Actually, let's select the vertices. And we could select these guys right here. And we could move this panel forward like that. We can select these guys back here. So after you get a section of it, the modeling tools are a lot better, okay, than everything else that you have used for Syntheyes. It's not a pure modeling scenario, but so I'm going to go ahead and take the top here, and you could just slant it or do whatever you need. But if you need to extrude, you could take the edges. So those of you that like to stuff, you hit enter, and then you go back like that and try to follow the perspective of what you need. Okay. You can slant that everything a little bit more if you need to. And you don't need to be accurate at this stage, but know that you could do, almost about anything. All right. So essentially now we have like a capsule for that guy. This guy needs to be. Now if you need to rotate around it, just unlock the camera, and now you can rotate around the object. Okay. So I could see, oh, I went super far, right? But this will need like the bumper in there and kind of pull it back and stuff like that. All right, so if you have that, now you can project it. Now the cool thing about the model builder is we could find one frame, only one frame. You need to find one frame that is good, right? And automatically this will set up the projection setup for you. So if I go ahead and I select that card, right? I'm gonna go select the geometry, right? That's the geometry that I want. I'm gonna switch to object mode. I'm gonna hit bake. There's the car. And now what we could do is, remember that before I had to do that whole projection setup by myself, right? I did it by hand last time that we did it for the store. So in here with the model builder, what you could do is you could actually switch the export type to projection. And when you switch it to projection, if you're in a specific frame that you want, let's go ahead and find a good frame for this one, where we see the majority of the car without the door open. Right about there, maybe 21, we see the 8 or 6 there. Yeah. We change it to projection here on the model builder. And then we're going to touch bake. And what it's going to do is automatically, it's going to create on frame 7, that is the one that I'm on, all my projection setup. So I didn't have to do that by hand anymore. So my map painting could happen now right here. So the only thing I have to do is the bake geometry that I did, I will connect that to the apply material. Okay. I'm going to take these guys over here, option C. I'm going to move it down here. This is my scene. Let's go ahead and take the camera right there. This is my camera, my render cam. Let's take that right there. And let's hit 1. And there's my guy. So now I have the vehicle right in there. Now you will see semi-transparent, and the reason why it's semi-transparent is because I don't have the alpha applied to that. So a lot of you will get that. So if by some reason you need an alpha, make sure that your footage in your read node, your footage has that auto alpha set to on. If not, just shuffle it If you don't have an alpha, that's what it will do. All right, so essentially now what I will have is, I have the vehicle in there, right? So now we have the vehicle. We could do anything that we want. We could damage the tire, reproject that tire back in, or anything like that to make it look like it's actually like a flat tire or something like that. It will shift the perspective, which is what we want. We will rotor only the area that we want to keep. Same idea as before. And then we will have our patch pretty much done. All right. So essentially, this is what you will see in the 3D world. And that's how we will approach it in this scenario. Let's put a grade in here very quick and gain up. So you can see it on the 3D side. So yeah, so that's pretty much the setup for this. So essentially, in Nuke, you could do the whole process that we did in Syntheyes, but internally, just in Nuke. That's the projection camera that shows up. So that kind of gives you an idea of how the camera tracking systems work in the two different packages, and how you can model one and how you can model on the other. Nuke's requires a lot more nodes, definitely, than Syntheyes, because Syntheyes is its own little package. In Nuke, if you want to model, use something. If you want to track, you use the tracker node. If you want to tweak everything, it's inside the tracker tab. But essentially, with that, you could actually rebuild the whole geo, the whole environment, and get something a little bit more acquainted out of it. So if I need to rebuild now, I will take, let's say, this guy right here. Even though I didn't create that card with the model builder, I could literally use a frame of that as well. So let's say this card right here, I didn't create it with a model builder, but I know where it exists, right? So could I do a projection setup for that card? And the answer is yes. We could actually do it. So what I'm going to do is I'm going to take the model builder here. Let's go ahead and link this guy right here again. And I want to project the ground from the first frame, right there, into that new card. So I'm going to take model builder. And even though I'm not modeling the ground with it, in this case, I could just bake a projection setup if I want to quickly do my projections for my map paintings and stuff like that without building by hand. It's like a preset. It's like having a preset in there, and you can build projections very quickly as soon as you have the camera move. You see? So that way, this setup right here, the only thing I have to do is where you see this frame hold right here, that's where the map painting goes. And that's where you always project. You see? That's the trick. So you can use the model builder, not necessarily as for it was meant to be used, that is modeling and all that stuff, but just for setting up your projection cameras a little bit quicker than going in by hand and setting it up every time. So now it's frame one, and we give you the name in there. Cool. And now what I have to do is take this geo, replace it for this, sound effects and everything, and then connect this to my scene. Now, so if I look at this now, I should have the ground and I should have the plane. So let's take this guy, option C. I'm going to color correct just the internal setup there. There we go. So now I have the ground plane as well. So if I need to do any type of work on that ground plane, remove the highlights because we need to remove the whole car and stuff like that, there it is. If we need to remove the stuff on the background, you see that the car is over it, but anything on the background we would do the same idea and stuff like that, and pretty much that's going to be what it is. So that kind of gives you an idea that you could do a lot of work. So if we need to remove that line and put like yellow lines, striped lines, because it might be like we want to make it look like the Pacific Highway on California, and the guys, you can see, the ridge, right? You can see the water on the background, and then maybe a city on the back. We are able to do that if we are able to freeze it. Remove all those lines, put new lines in, then create the rotors for the stuff, put the tire, like if it was a flat tire, stuff like that. So that's the important of camera tracking inside of Nuke, how you can quickly do that instead of having to jump to Syntheyes. And this is another option. It's not the only option, but it's another option if in the studio you don't have access to Syntheyes. The current one that I'm working on, they don't have Syntheyes. They don't have it. They depend on whatever the artist knows. And the only thing that they have is Nuke. They have Mocha, you as the artist bring whatever tracking software you're allowed to in. So they don't have the software control. So essentially, I have my own. So Nuke is the idea, and anything that you produce, you have to put back. So that means when you're working in the studio, any script that you produce, you have to put it back. If they don't have the software, at least they have the script, and then they can get the software and stuff like that for what that script is. So that's why I prefer tracking in Nuke sometimes when I'm working in comp, just to make sure, everything is translatable between the studio and I. So sometimes even if the studio doesn't have it, you could help the studio just by doing that. So you can't depend on softwares being there when you want, right? You have to apply the knowledge everywhere, like an actual umbrella. So that's why it's more important the knowledge than the software. You see the same knowledge that we had in Syntheyes, what I demonstrated today is that you can transfer that knowledge to Nuke's camera tracker. The same areas that you found in Syntheyes, they just have different name and different locations, but exactly the same thing. They all have to deal with the same issues. If you go to PF track, it's node-based. Exactly the same things that you're going to deal with here. First do the preparation, and you do the track, then you do the solves, you refine, same idea. All the software is the same. If you break it down to the same steps, it's always the same in any software. If you take Buju, a 10 grand software, same idea. Same preparation. So we're going to leave it at that. Go ahead and take a break now. I need to get more coffee. So it's 10:45. Let's give you guys a break. And like give myself a break too. 11:35. That will give you. No? Yeah. 10:45 to 11:45. Yeah. So be back by 11:35. You guys are asleep the same way as I am. Like portfolio is actually hitting you guys hard too, right? Yeah. So it's like the double whammy. All right. So I'm gonna go ahead and stop this recording very quick.